In this video, we'll present the implementation of Feedforward in virtual reality and show how it can help users interact. Feedforward is an HCI concept. Feedforward occurs before the user's action and tells users what the result of their action will be. The iPhone unlock screen is a canonical example of feedforward designed into 2D interfaces. However, mimicking 2D feedforward in VR overlooks the VR-specific interaction space that emerges from presence and immersion. We identified three main stages of feedforward in VR: triggering the feedforward, previewing actions and outcomes, and exiting the previews. Each of these stages have their specific parameters with different variables. Together, these make up our feedforward design space in VR. Please refer to our paper for a detailed discussion about the design space and its parameters. Next, we present the feedforward VR system, which includes three real-world applications. We start with the car demo. The car demo depicts a situation in which the user does not know the actions involved in starting a car or where to locate the objects needed for this. In the demo, the user can start a car by pushing its ignition button hidden under a yellow cover. In Stage 1, we trigger the feedforward according to the user's proximity to the car wheel. This is an example of a location-based trigger. After the user triggers the feedforward, in Stage 2, the actions, outcomes and avatars involved in the interactions are previewed by the feedforward. Here, the targets of the preview are the car controls related to actions and outcomes and the avatar. Once the feedforward is triggered, we show a preview of the actions and the outcome. Here, the targets are duplicated and ghosted, showing the user what movements to perform. The user can follow the movements at the same time with the preview. The outcome is not only visual but audio, the car's motor being started. These are examples of direct actions and outcomes because they replicate what happens in the virtual space when starting the car. We can apply feedforward in many ways. The previews can take the user's own hands and do the actions. We call this embodied feedforward. Here the user loses control of their avatar momentarily. In Stage 3, the virtual environment must return to its initial state. We exit the preview by using a rewinding transition and turning back the feedforward clock until all actions are undone. In this example, the exiting happened after one preview. Then, the user regains control of their avatar. We can also exit by allowing the user to interrupt the feedforward, for example by touching the targets. When the user intends to do the actions themselves, we stop the feedforward. To trigger the previews from afar, we let the user embody the feedforward from the first-person perspective. In this preview, the targets are ghosted and duplicated. We improve their visibility by offsetting them from the original objects to prevent overlap issues. Since feedforward is a preview, the user is taken back to their initial location just at the moment of exit. We can combine targets, ghosts and duplicates to obtain different kinds of feedforward. For example, we can also have as targets just the avatar. In this case, the original objects are not moved. If we have only the actions and outcomes as targets, the hand is not shown in the preview. In this case, the objects move by themselves. Next, we describe the door demo. In this demo, we implemented a door that opens in an unexpected way. The door is opened by twisting the handle and sliding the door, instead of pulling it. In this example, feedforward can be used to preempt the user's confusion and inform them how to open the door properly. In the first phase, the user triggers the feedforward by approaching the door handle. In this example, the preview is shown several times before exiting. Interrupting the preview to exit can sometimes be jarring, because we return the objects to their initial state without any transition. We can improve the user experience by using duplicates. In this case, we maintain the continuity of the environment when the user reaches for the original objects. We can also maintain continuity and prevent occlusion issues by only showing the ghosts at the location of feedforward and disappearing the original objects. We call this the feedforward lens. Upon interrupt, the lens simply disappears. We move on to our last demo, showing how feedforward can help users discover action possibilities in a virtual kitchen. In this demo, we implement triggering by gaze. The user looks around the room, and one by one, the available interaction with the virtual objects are revealed to them. In this feedforward, the previews target the actions and outcomes, and the avatar. Here the avatar is also duplicated and ghosted, while the action and outcome visual elements are not. For each available interaction, A ghosted hand flies away from the user to preview it. Most of the types of actions and outcomes in our implementation are direct, except for the iPhone unlock screen. This example shows how Feedforward can be used for discoverability purposes. We make the Feedforward system implementation and the 3 demos available on GitHub. Please refer to our paper for a broader overview of the Feedforward types available and more implementation details.